Thank you. Thank you for spending your day with us, for being here, joining us on a day of presentations and hopefully learning for all of you. I understand many of you have flown in from different cities in Australia, but also from outside Australia, so thank you to all of you. And you have now heard from Chris a little bit about the momentum that Snowflake is having. More important, you heard about the results that some of our customers are realizing with Snowflake. And I love the story of Martin. I got the chance to have dinner with Martin yesterday. So I've known him for all 24 hours. But I can tell you he has scrutinized technology, and he likes to try and see what works, what doesn't work, what are the use cases that fit. And that carries a lot of weight for me to hear his choice and his bet on Snowflake, because it's not a light decision. Now I want to go a little bit deeper into the product. What is Snowflake? I want to share a little bit on the trends that shaped Snowflake when our founders started the company in 2012. And those trends are also true today. I want to describe the actual product, or what is it that you can do. How do we do it? The first time I heard about Snowflake is like, that doesn't sound right or possible. But once you understand the underlying architecture, then you can say, oh, it all makes sense. And then I want to go a little bit deeper or broader than just data warehousing. The momentum that we're having with our customers is quite significant. And all the time, we are in touch with what is the next need, what is the next opportunity, what is the next type of data analysis or value creation that you're finding friction, how we can help you. And you'll see us over time expand beyond just data warehousing and just analytics. I'm not saying, oh, we're done with analytics. I think data warehousing has been going on for 20 plus years, and we have many years of continued innovation. But at the same time, we want to provide a broader suite of technologies and evolve into a broad data platform. So let me get started and discuss the trends. As I mentioned, in 2012, two founders, as Chris told you, ex-Oracle senior folks, they saw like the movement and technology movement on customers, movement on data, and that's what led to the creation of Snowflake. So let me go through the list. First one, I don't think I need to convince any of you that the trend is towards having more data. There are many estimates floating around. All of them converge around similar numbers. The cumulative sum of all data that has been created, as far back as we can count, to today is roughly 30 zettabytes of data. That sounds like a lot, or sounds like a big number. It's hard to think of what a zettabyte is. But the most stunning thing is that the estimates say that by 2025, which is mere 6 years from now, we will have 5 times as much data than those 30 zettabytes. So if all of you feel that, oh my God, I'm drowning in data and there's a lot of data in front of me, I would say buckle up, because a lot more data is going to be created. And of course, it's not just the trend of more data, but it's how it's getting created. We've gone from humans entering data into terminals that make it into computers to a lot of machine-generated, sensor-generated data. And also the shape of the data has changed from typical rectangular columns and rows data to semi-structured and unstructured data as well. Then there's also a trend around the number of users that want access to this data and want to get value out of this data. It used to be a thing of IT and a handful few, and you would just go and say, can I please get a report? And if the IT gods align, then yes, you can have your report, and we'll talk later about when. But now, the most important thing is everyone needs data to do better in their job. Everyone needs insights. Everyone needs the feedback loop. So the thirst for data is on the rise. Then I alluded to the speed of responses and the speed of answers. And not too long ago, and in some companies, it may be still true today, answers are measured in weeks and sometimes months. I met with a financial institution from Europe, and they were telling me that every new report, still you put a request, it runs through a process, and 30 days later, after all sorts of governance and controls are executed, a report comes out. And I don't want to be too negative, too critical. There's reasons for things being that way, but that's not the business reality that all of us are in. And I don't know how we answer the question on, can I have data now? Now is sometimes in 5 minutes from now, 10 minutes from now, that sometimes is too late, because businesses, new products, new services are all about faster time to insight and faster answers. And then as more data comes up, and all of this need of data-driven products, data-driven services emerge, now there's the need to govern it. Before, when data was like in the corner that nobody quite paid much attention or cared much about, yeah, who cares if we have the right permissions and controls, et cetera. But now it's front and center. I don't think I have a single customer conversation where we're not talking about governance and metadata and lineage and security and privacy and data quality. So that is also a very important trend. And the other trend is around data sharing. And I think about it in terms of a lot of data points don't quite tell you the story unless you put the data in context. If I tell you that sales for your company are up 20% year over year, how do I know if that's good or that's bad? I need other data to understand that. How's the market doing? If the market's growing at 10%, then I'm doing well. I'm gaining market share. If the market's doubling year over year, I'm doing terrible. And that's part of our realization that data needs other data to make better decisions and to have faster insights or better insights. So these trends, I don't think I need to convince any of you that they're real. They were true 6, 7 years ago. I think they are even more true today. And I think there's nothing any of us can do to stop it or change this. So this is a given. Where you do have some choice is on the technology that you use to make sense out of that data. And unfortunately, for quite some time, there's been no real good choice. And I evaluate the different types of technologies available, both looking at how much data I can process in a single system, how many users and how much concurrency I can have, the types of answers that I get, how fast, and of course, I like the notion of, is it a SQL database or not? Every few years, some new technology comes and says, this is the end of SQL. Yeah, some of you have heard it. I've heard it from XML and object databases, and at some point it was called NoSQL. And it just keeps coming back. Everyone just tries to make it look back like SQL. So there's been no end of data warehousing technologies on-prem. This includes both a server, database server that you deployed and installed, all the way to clustered systems and clustered solutions. And for the last maybe 10 plus years, all the hot technology was around appliances, because configuring cluster systems was too hard. So the problems with this technology is it was difficult to put all your data in a single appliance or server. Right? At some point, you ran out of space, and that was the end of it. Of course, then you start buying more appliances, and that creates different types of problems. Similarly, because of the fixed resources, it was difficult to say, I'm going to open all the users that want access to this data and just pound on my server or my appliance. that usually didn't end up well. What those systems were very good, and Peter mentioned in my past life I built a lot of these, so I'm not trying to be too negative. Those systems actually gave you answers at quite reasonable speed, and I think the model was well liked. The SQL relational database model has been proven to be successful. And there's ecosystems and partners and BI tools, all of them work with that. Then as the cloud is emerging, also the data warehouse cloud native solutions emerge. And I did native in quotes because that's how you'll hear about it. It's like, oh, you better choose a cloud native solution because it comes with integrated with the rest of the stack, et cetera. And all of those solutions are nothing but the same technology that was working on-prem. And instead of me shipping you some service in an appliance, I'll give you some VMs. But all of these limitations of that technology are still present in the cloud services. Yeah, maybe the time to grow a cluster or shrink it is a little bit better than having to wait for some service to get shipped for me to grow my appliance. But all the fundamentals of it are exactly the same. So you have restrictions on data, you have restrictions on users, and the same fast answers in the SQL model are still valid and welcome. Then there was the big data wave. And the big data wave was trying to reconcile the trend of lots of data with the limitations of the technology. Right? How am I going to deal with these large volumes of data? And this is where it includes the Hadoop systems and data lakes and put data in raw form. And those technologies, I think, check on the volume of data. Finally, I can put all my data in one place. There was some marginal progress on concurrency and ability to serve all the users. Oh, but we had to give up performance. And yeah, at least we have all the data. Right? That was the trade-off. And then there's the SQL model. I think Hadoop comes out, and it was amazing that you could have like petabytes of data. But now you have to learn an entire different way to interact with the data. And I think the last 5, maybe 8 years have been all around trying to make Hadoop or big data-like systems look like a SQL database system. So in reality, there's been no great choice to deal with the trends that I mentioned. And of course, I would say that was true up until Snowflake showed up in the market. The taxonomy is not a self-serving taxonomy. Like, of course, I wanted to have 4 greens at the bottom. But I honestly believe that if a technology like Snowflake had been available in 2010, 2008, where you got your SQL model, where you got the fast answers, but you could have all your data in one place and deal with the needs of all your users, probably the big data wave would have not happened because it would have been a natural evolution of the database technology. And something that is important for all of you to think about is that the trends that I just described, they're real, they're happening, and I said you have no control. But your choice on technology can make those trends be a challenge or an opportunity for you. And that you can influence, and that's obviously part of what we're trying to convey with you on the potential and the value of Snowflake. At the same time, I would not want you to evaluate Snowflake just like another data warehouse. The most interesting thing that happens when our customers start to think about Snowflake, understand the Snowflake model, and use Snowflake, is that there's a paradigm shift, there's a mindset shift, where I am no longer driven and operating as a function of the infrastructure, but I am shifting to be driven by the business needs. And I'll give you examples of what this means. Capacity. The way you plan for capacity, the way you purchase capacity in the old world, and it's also true in the cloud-native databases, more so in the appliance world, is you have to decide upfront what your capacity needs are going to be 3 years from now. It was a little bit stunning. Like, do you want the 80 terabyte model or do you want the 200 terabyte model? And we as an industry used to ask questions on, and do you want the high performance model or the high capacity model? And you make a decision right there for 3 years out, and then for the next 3 years, all that you're doing is you're jamming the business needs to sort of fit within that capacity that you purchased. With Snowflake, all that we're saying is, yeah, you can do budgeting and planning, et cetera, but the capacity is there to address the needs when you need them. If a minute from now I need 10 more servers, I'll instantiate them a minute from now, use them for as long as I need them, and return those resources. Chris mentioned about this customer that does the end-of-week computation with 2,000 servers. That is unthinkable with traditional technology. Then there's the notion of silos and copies. And this one I personally feel strong about. Because the technology, the infrastructure, all these wonderful database systems from the last 10, 20 years, forced upon all of you, all of us, because I've been a victim as well, forced us to either make copies of data or start partitioning and creating silos of the data. Again, it's a byproduct of the limited capacity. If I cannot put all my data in one system, then I have multiple systems where the data lives. And God forbid someone from the business needs a report that combines both of those, because it gets harder. But also, if I cannot fit all my users and all my demand in a single system, then I start to create copies of my data. And I don't know anyone that ever said, oh, it's Monday, I'm excited, I'm going to create another copy of my data this week. Because it comes with all sorts of governance and problems and nightmares. And part of the Snowflake value proposition is, forget that. Put all your data in a single place, single copy. And again, all your needs adapt around that single copy. And the last one is, where's your time going? We obsess at Snowflake about removing friction and removing unnecessary activities where your time is not going towards getting value out of data, getting insights out of data, making your company more insightful, making your bosses more insightful, making your products and services better. So where your time goes is in managing the data, not managing the infrastructure. And last comment before we start to dive a little bit deeper into technology is that Snowflake represents true disruptive technology relative to all prior art. And how you think about it and how you evaluate it matters. I have a picture of the iPhone relative to an old Nokia phone. I'm not trying to say, oh, Snowflake is the iPhone of data warehouse, because I have no idea what that means. But what I'm trying to say is, imagine if you had evaluated the iPhone just based on the characteristics and capabilities of the previous generation technology. Oh yeah, I have an iPhone, it has a screen, I can place and receive calls, looks pretty good. It would have completely missed the headroom and the new capabilities that a new platform provided. And that, I think, is the most important thing to me. Yes, we'll replace existing data warehouses all day long, and we'll beat query performance and do all those things. But the design of Snowflake has created something that generates so much more headroom for us to deliver more value to you. And a lot of it is available to you in the product today. And I'll go into some of the details. When Chris mentioned our founders did not start from, oh, it was a Postgres database or it was somewhat, no. Built from the ground up. Every single part of a database stack. The storage engine. How can I build a brand new storage engine leveraging the elastic and dynamic nature of resources in the cloud? The query processor. How can I build a query processor? Blah, blah, blah. Same thing for the language compiler. Same thing for the client connection. Same thing for session management. Everything was reimagined and reinvented for a new technology stack. And the other insight is, once you are in a previous paradigm, like this Nokia phone, shifting to the new paradigm is very hard. It's almost easier to start from scratch. Any of you want to give me the list of what are the features that I need to add to the phone on the left to make it the phone on the right? And it's something like, I need a new keyboard, a new processor, a new operating system, a bigger screen, a touch screen. By the time you're done with the list, evolving one into the other one is even harder. And that's what personally gave me a lot of confidence to join Snowflake, which was like, ooh, I wouldn't want to compete with this technology because I know how disruptive the nature of what we have is. So enough of the framing, but it's very important for me to convey to all of you, Snowflake represents a new chapter in data warehousing and data analytics. But now let's go into, okay, what can I do with Snowflake, or what is Snowflake? I don't know how deep all of you are. And like, okay, you keep hearing that it's amazing, but what is it? And everything in Snowflake starts with what I already alluded to, the ability to put all your data in a single central location. And then the fun begins. I could, for example, say, I want to create a cluster, compute cluster, that is the one that is loading data into my Snowflake account, Snowflake instance. In Snowflake, we have the notion of the power that you give to a cluster or a virtual warehouse is the name in the product for these clusters. And you can say, I want it to be low powered, and we use t-shirt sizes, small, medium, extra small, large. Or I can go big power, large, and 2 extra large, and 3 extra large, et cetera. So I could say in this example, I want a small power cluster that I use for loading my data. At the same time, I can have a separate compute cluster, a separate virtual warehouse that uses maybe a little bit more power to do data transformations and data pipelines. And the interaction between these two clusters is completely consistent. The transformation cluster will only see data once the data loading cluster has finished executing on it, and there is no resource contention whatsoever between these two clusters. At the same time, maybe a financial team is running on, I don't know, end of month, end of quarter financial reporting, and they need more power in a cluster to run the analytics that they need. That activity, again, happens completely isolated from the other two clusters. And then you can see how I can keep adding more departments and clusters all day long. So I can say, oh, data science, those are the ones that send the large queries that make everyone slow down, right? So you can give them a separate cluster, and maybe they start with a lower power. If any of these use cases needs more power, one command in Snowflake, power goes up, does not interrupt any activity, no quiescing, no read-only, no interference with all of the other clusters. Just data science got more power. And if data science wants less power, they can turn it back down. And the other ability, and Chris alluded to this, imagine that one of your departments or one of your business units has a dashboard or a set of users, and they're pointing the dashboard or the BI tool against a separate cluster, a separate virtual warehouse. And I always like to say, Snowflake is great technology, et cetera, but at the end of the day, there's no magic. Right? At some point, there's some physical CPUs, some physical memory, and if you pile in with thousands of users, at some point, we're going to have to say, OK, slow down, there's some queuing, because there's physics. But with Snowflake, what you can say is, you know what? For those situations, I want to configure Snowflake such that if any one virtual warehouse, if any one cluster is going to get overwhelmed, I want Snowflake to create additional instances of that same cluster and service all the traffic. And so this is what we call the multi-cluster warehouse. And you can specify the minimum number of clusters or instances in the cluster, the maximum number, and Snowflake will magically or automatically grow and shrink the number of clusters based on the load. So the infamous spike at 8 a.m. morning, people looking at reports. the infamous spikes where holiday shopping seasons or summer breaks, what have you. You can configure Snowflake to deal with the load, spin up, spin down clusters as needed. Excuse me. And more important, for any one of the clusters, if there's no activity for those clusters, then we will spin them down, and you only pay for clusters that are active and running at any point in time. For those of you that have seen or have been doing databases and data warehousing for a number of years, what I just described sounds a little bit too good to be true, and what Chris said is true. Go try it, it is true. And we have many customers that can attest to all of this is actual technology that works. But the more interesting question is, how does this work and what's going on behind the scenes? And the answer is architecture. To me, it's difficult. Sometimes we're like in senior executive meetings, CIOs and CEOs, and they want to know, so how is Snowflake different? And we sort of had to go down into the weeds and talk architecture. Yes, I can tell you all these benefits, but the real answer is how Snowflake was built is what gives all these amazing capabilities. For the last 20, 30, 80s, yeah, 30 years or so, every single scale-out database system has been built with one of two architectures. Either shared disk, where you have a number of compute nodes connected to a single shared disk, or shared nothing, where you have a number of compute nodes, each one with a shard or a subset of the data. Every single database system you have is one of those two. And they all have, what they have in common is that it's a single cluster accessing some data. Pick Redshift, Teradata, Netezza, Azure Data Warehouse, all of them shared nothing systems. Back in, I think it was 1980, there were already academic papers, Michael Stonebreaker, and like the real top database researchers, and what is the best architecture, shared disk or shared nothing? And for the most part, for analytics, shared nothing has been more popular, but every single system had the same architecture. And Snowflake represents the first time in 20, 30 years that there has been innovation in how database systems are built. And we had no name. I don't know that is the most creative name of all, but we call it a multi-cluster shared data architecture because you can have multiple clusters and some shared data. But it's very, very important because that is how foundational this is. For 30 plus years, everything had been built based on the same assumptions, based on the same research. And our founders, which I consider borderline in the category of geniuses, they said, no, let's come up with something new. And the outcome is what you saw. And in more detail, so since we run on multiple clouds, we have at the bottom of the architecture a cloud agnostic layer that effectively abstracts the specific nuances and ways that we interact with our cloud partners. For anyone that has been in the database business for a long time, there used to be a hardware abstraction layer because it was a similar concept, but now it's all in the cloud. For the ability to give you a central store, we use the object store provided by the cloud provider, S3 and Amazon, Azure Blob Store in Microsoft, and Google Cloud Storage for Google. And we use that as the central fabric to put all of your data in there. Of course, we manage the format, we columnar compress it, you come out ahead quite well in terms of price per terabyte because of our compression. We always encrypt all our data, so there's all sorts of benefits on how we do it. Then there's this middle tier or middle ring in the diagram, which is the compute layer. That is when I was showing you the example of the finance department having a cluster and the data science team having a different cluster, bigger or smaller. All of those clusters are defined in that middle tier. And you can have as few as 0 if you want to, and you can have as many as, I don't think we know the limits. I know of many customers with several hundreds defined and running with several hundreds concurrently. And that is where the ability to have all the data and all the users that you need come from. Imagine if you can keep spinning up clusters, as many as you need, without making any copy of the data. And that starts to be very empowering and very differentiating on not only I may be able to do what I need to do today better, but the opportunities and the things that I could do start to open up. When I talked about the clusters in the middle, I said all of these clusters are consistent. All of these virtual warehouses know exactly what the other ones are doing. If one of them creates a table, the other one can insert. If one of them creates a user, the other one can connect under that user. And how are all these different compute systems coordinating and interacting? How are they kept consistent? And the magic is this outer ring, which we call it the scale-out services, or sometimes we refer to it as the cloud services layer or the global services layer. And effectively, all state for a Snowflake instance is kept in that outer ring. All query optimization happens there. All metadata management, all transactions happen. So if one compute cluster is modifying data under a transaction, other clusters don't get to see that change until the transaction either commits or rolls back. And that is virtually impossible to do with any technology out there today. And you can say, well, but I don't know if I need that. Consistency of data matters. I think in the era of big data, we got into the, just to be able to deal with all my data, OK, I'm fine if it's a little bit less consistent. And those inconsistencies at some point show up in some dashboard that go to a higher up and like, eventually it'll be consistent. I don't think that's the right answer. So we need a transactional engine that can also scale to large volumes of data and large numbers of users. And that is what Snowflake is. So between what Chris shared earlier and what I've talked so far, you get some of the characteristics and capabilities of Snowflake. Centralized data, don't need to talk more about it. Columnar storage, I already mentioned. Proprietary format, amazing compression, and amazing ability for us to speed up query processing by virtue of understanding that format natively. Native support for semi-structured data, whether it's JSON, Parquet, Avro, ORC, XML. You ingest the data into Snowflake, and under the covers, we automatically columnarize it so that if you run a query extracting only part of your semi-structured data, the performance is comparable to if you had sharded the data up front and stored it relationally. I don't know I don't think Chris mentioned it, but he would say the ability for semi-structured data, native support in Snowflake, is probably one of the most differentiated capabilities, especially in the early days, where it was very unique for us to have this. Then the notion of micro-partitioning. In Snowflake, there is no ability for you to manually partition the data. Under the covers, what we're doing is constantly creating lots of micro-partitions, and that is also a concept that our query optimizer and a query engine knows to deliver some of the performance that gets us to beat almost all competitive solutions out there. But then I mentioned that a different approach to building the system, the architecture from the ground up built for the cloud, comes with some additional capabilities and dividends. And examples of those, I can give you examples all day long, but some of them is the ability to do time travel. Time travel in Snowflake is I want to be able to query a table or run any query as of a point in time in the past. I always like to say how good it would be able to see the state of this table as of 3 minutes ago, just before I accidentally deleted all the data. And it's a real world situation. We all sometimes think, OK, maybe someone else is going to do that. If you accidentally drop a table on most database solutions out there, you just created like weeks of work for you and pain and outages, and because it's not easy. It's not easy to recover data. In Snowflake, because of this time travel capabilities, the way we journal all changes in the system, if you drop a table by mistake, you can run a command, undrop table, and you're back in business. Twilio is a customer of ours. They were in our San Francisco summit on stage. And they said, oh, when the sales vendor told me that you could recover a table that is dropped, we made fun. We would never do that. And it just had happened to them like a month ago. Someone had 2 tabs in their browser, and one was production, one was test. They truncated the table in the wrong tab. And the good news is, of course, he was on stage telling the story how a minute later everything was back to as if nothing had happened. These are capabilities that fall from our architecture and give you a lot more power than what you have in traditional systems. Cloning, the ability to do cloning. You can take any single table, schema, or database and clone it. And by cloning, what we do is we do a virtual copy of those objects, say a table. They point to the exact same storage. And only if you modify either one of the objects, then we start to track the deltas or where those two have diverged. So you say, I don't know if that's useful. Then you start to think, oh, some regulatory requirement says I need to have a clear snapshot of what this data looked like on this date. Create a clone, and you're done. That is a snapshot of what the data looked on that point in time. Or how do you test your data pipelines? It's a very hard problem to test data pipelines, because either you have a completely duplicate environment between production and test, or you have some sample or some simplified test environment, and often you catch things, but often things break only when it's working on the production data. With cloning, you can clone all the objects that you need to test a transformation or a pipeline, run it. Once it's done, you can delete all the clones, and the cost is minimal. Or how often for data science scenarios, it's like, I need a copy of production data. And of course, that turns into a 3-month request for lots of reasons, not just technical. But here, if you want the technical piece, you can say, clone this table, clone this data, and there you go. You have a copy without having to make or pay for that copy. Again, only to the extent that things diverge. And the last comment is around security. We have built Snowflake with security in mind from the ground up. Every single part of the system, not only we've given you lots of controls, role-based security, granular permissions, et cetera, but also how we build the system. We know, we understand, I talked about the importance of data and the importance of governance of data. We know the value of data. Not only is sky high, but it's on the rise. And we do everything we can to secure the environment, to make sure that you can sleep well at night, and all of us in the product team also can sleep well at night, knowing that we have the right protections. We could do like a 2-hour session on what all the things that we do in security. At this point, we have customers in all sorts of regulated industries, financial, healthcare, et cetera, and I have full confidence that there is no security team or security set of requirements that we have not been able to meet, given all the work that we've done. Often, when I talk about data warehousing and Snowflake and all your data in one place, the question comes up like, yeah, but you're the data lake, and I was thinking about talking to you for an analytics solution, a data warehousing solution. This is not a data lake, right? So I usually start with okay, what is a data lake? And a data lake is nothing but a pattern. And it's not technology. It's not like, oh, can you give me 2 data lakes? Give me the Microsoft one. Data lake is a pattern. And it's a reasonable pattern. You say, keep all your data in a single place. So 90% of your governance problems got simplified. They didn't go away, but it got simpler. Keep it in open formats. Keep it in as raw form as possible. So if you change your mind about, oh, I wanted to redefine the metric, you have the optionality to do so. And as part of that, you do a schema on read. Everything I just described, of course, you can do with Snowflake. Right? But hopefully, from everything that I talked about, you can do it. Yes, we store it in our own columnar storage, but we ingest data in Avro, Parquet, all sorts of standard formats, and we can unload data in those formats. So if you can get it in standard representation and get it in and get it out in standard representation, does it meet the bar? I would say absolutely yes. But more important, with Snowflake, you get a lot more. And it goes back to my initial slide on big data and how to get some of the attributes on scale and volumes of data, we gave up on other things. Why do we need to give up on governance and fine-grained permissions and role-based access control? Why do we need to give up on transactions? And yes, I am aware that there's an army of people bringing in transactions to Hadoop and big data systems. We'll talk a little bit about data sharing and global. And most important, the performance. Having a data lake should not imply trading off performance. Why? Think about it. Why do either I get all the data or I get fast answers? Pick one. False choice. And the last one is the managed service. I think it was Gartner that said 80 or some such percentage of data lake projects fail. Most of them stuck in just managing the infrastructure. They never got into how well it was performing and cost effective. No, just getting it running. That's where many fail. Snowflake is a managed service, no infrastructure. So let's talk about that. What do you do in terms of administration and traditional systems? There's all the infrastructure piece, and yes, you need to buy some hardware, you need to install some software, you need to provision storage. How often any of you have run out of storage, or some alarm says you're like at 90%, and when you get to 100%, bad things happen, and those are the most painful errors because they're completely unpredictable. The notion of doing backups, the notion of doing security patches. Then there's physical design. How am I going to partition the data and what index I create? And if I create an index here, it slowed down this other operation. And there's all this fine-tuning on the physical system. And vacuuming. Oh, I forgot to vacuum my storage and things got super slow. It's a true story. It happens a lot. Yeah, there's some job in the background that is supposed to vacuum, and somehow the job went on vacation or something and didn't work. And then the last one is query tuning. How much effort goes into giving me the statistics and memory knobs? It's like, in general, the industry has gotten better, but 20 years ago, there was like how much memory you want for your log manager? And like, what are you talking about, right? Parallelism, query plans, hence workload management. All of this is the traditional approach. And in reality, staying true to what I said up front, that we want you to spend time on the data and the data modeling, not on the infrastructure. In reality, none of these operations in this slide you can do with Snowflake. There is one knob that you can figure on the data storage, which is how you cluster your data, and that has an impact on performance. And that's it. There's one knob. Other than that, your entire time should go into the data model. We cannot do data model for you yet, or I don't know, even if at some point, because you know your data, you know your metrics, you know your business. But that's what we're trying to appeal to you in now you have a ton of time to go and build the right data set, the right data volume, et cetera, and not spend time on the infrastructure. I also like to say that for teams, either some of you or some of you in your teams, et cetera, that are used to all this knob tuning and tweaking and optimizing, Snowflake does come with like withdrawal symptoms. It's like, oh, I don't know what to do. And it's true. I hear a lot of Resistance. Oh, but I cannot do this. And like, but why do you want to do that if you don't need to do it? Right? And it's a little bit of the mindset shift. Again, I'm not trying to say you do not need administration. That is far from the message. But it's shift the administration of the data to different activities. Things like data governance. Do you have the right permissions? Things like data model, et cetera. So for sure, there's things to do. But it's not the mundane things that, frankly, we have a bunch of machines that do it, and they do it reasonably well. So that covers the part when I talk about Snowflake as the core data warehouse and the core analytics system. But I started saying that we're going towards a data platform, a broader area, broader set of use cases and capabilities. So let me cover these 3 topics in a little bit more detail. First one is around data pipelines. And if you think what a pipeline is basically the ability to take data from some source state and put it in some destination state. It could be changing location or system, or it can be changing form. And usually if you decompose the problem on building a pipeline, it comes to one or two things. You need to read some source data, or you need to do some transformation on that data. So on the ingestion, on the reading source data, we have a serverless service. It's called Snowpipe. And effectively, what you feed to Snowpipe is a set of files that live in your object store, S3, GCS, Azure Blobs. And those files get ingested into Snowflake. Usually, they land in a temporary table or a staging table. We also have a Kafka connector, for those of you that are using Kafka. And it does the same thing. It just integrates with Kafka and takes each topic, converts it into a table. Under the covers, it's also going through Snowpipe, but it makes it fairly easy to ingest it into Snowflake. I'll mention super quickly, which is not in the context of ingestion, our ability to do unloading of data and unloading data at scale. We want your data to be in Snowflake because you find value of your data being in Snowflake, not because you're stuck in there, which is true of some technologies, right? And I've heard stories on yeah, why would we optimize the unloading path, and the harder it is to get the data, the better. Not us. We have a bunch of people making it better every day. How do you do parallel unload and fast performance? Not because we hope you take your data elsewhere or your business elsewhere, but because we want to be very clear. You have a choice. At the same time, there are some use cases where someone has data in a data lake or an existing S3 store, wants to transform it in Snowflake and put it out there. But philosophically, we are very focused on giving you value and motivating you based on value to use Snowflake, not based on your data is trapped. Usually, once you've ingested the data, you need to transform it. And now think of what a typical transformation looks like. Often you want to enumerate what has changed on some source data, and then apply a change on that delta changes. And then you do this over and over. And we have 2 simple but powerful primitives. One is called a table stream. And what a table stream does is you can define a table stream on an underlying table and tell it, enumerate what has changed from this table since the last time I read from the stream. Effectively, it's a change data capture CDC mechanism on a table. The other primitive that we have is the notion of a task, which think of it as a scheduler. And now you can combine these two, and the typical pipeline that you can build to transform data in Snowflake is you begin a transaction because you want your changes to be transactional. You read from a stream to see if you have new data on your table or what has changed. You apply the transformation. We have full SQL, insert, update, delete, merge, what have you. And then you commit your transaction. And as long as that is running on a regular basis, you have a pipeline that is scalable and transactional. Whenever I talk about ingesting data, I think the first question I get is, well, do I really have to ingest all this data? I already have my single system of record copy version of the truth in my object store, my data lake, S3? Do I have to move everything in? And for those types of use cases, we provide choice. Our philosophy is we want to give you choice. We want to give you optionality. And we have this notion of an external table where you can define a table that points to storage that lives in S3, Azure Blobs, or GCS. And the definition of the table is in Snowflake. You can query it with our entire SQL query engine, but the files reside outside. Of course, there's a performance trade-off because we're going out to external storage as opposed to using data that had been ingested into Snowflake. But it gives you optionality. We also have the ability to define materialized views, both on internal tables, but more interesting, on external tables. And that materialization, a summary or a pre-aggregation, lives inside Snowflake. So imagine the path, and we automatically maintain it. So as changes happen on the source data, we automatically maintain the materialized view. And with this, what we do is we enable data that is living outside with summaries or filters that live inside Snowflake, all of it queryable and joinable by the same query engine, giving you as much choice on what do you want to ingest, what performance do you want, and you're in control. Then let me shift to the second area beyond data warehousing around global Snowflake. Chris already gave you the highlights of what we're doing there. We are running multi-cloud. We did the prior preview of Google 2-3 weeks ago. We will be announcing general availability beginning of 2020, and we'll expand to additional regions beyond. And you saw the same chart or the same slide in Chris's presentation. What I get asked a lot is, but why do you have all these regions if you told me you can have all your data in one place? Now you're making me have all data in different places, or what's the story? And the story is what you see in this why slide. Different teams in the company started with different clouds or in different locations, so now you have distributed infrastructure, distributed app infrastructure. There's regulation, lots of data locality and data residence laws where my data from Canadian nationals has to be in Canada. So that's now an imposed set of restrictions on where the data lives. And of course, there's disaster recovery. You don't want all your data in a single data center because disasters do happen, and when they happen, it's not pretty for anyone that didn't plan for the disaster. So our view is we want to give you a logical model, a logical view of where the data is. We have this concept of an organization, and you can have multiple accounts, and the different accounts can be in different regions, different clouds. But we give you a simplified single pane of glass to manage and understand your data, even if you live in a multi-region or multi-cloud world. Under the covers, we have actually taken all of the Snowflake instances in the different regions and different clouds, and everything is interconnected with a mesh built by ourselves, which enables the simpler model that I described, but it enables us to give you a global view of Snowflake. Chris mentioned some of the features and capabilities that are now available based on this global data center that we're creating across clouds. You can have data in AWS in Oregon. You can do cross-region replication. And when I talk replication, it's not object store type of replication. It's transactional replication. So data is consistent if you were to read it on the other side. You can cross oceans, cross continents. And of course, you can cross clouds. So we have a deployment here in Australia, both Azure and AWS. Depending on your needs, I'm not saying this is how you have to deploy it. But again, if you choose to, one command, and you can have data syncing between two different data centers, two different clouds, with virtually no effort on your end. Of course, database replication is a down payment for business continuity and disaster recovery. In addition to replicating the data, we also have the ability to do failover and failback. So the primary database, you can switch it from one side to the other, again, cross-region and cross-cloud. And we have the ability, or we will have the ability, it'll go into preview next month, to do transparent client redirection. So all your BI dashboards and your applications or your pipelines, if they're pointed to a virtual business continuity instance, when there is a failover, they can get redirected automatically. This is the beginning of many things that you're going to see us do in global nature, because we have now the underlying plumbing and architecture to simplify this multi-region and multi-cloud world that we all find ourselves in. Last but not least, let's talk about data sharing. Data sharing in Snowflake makes a lot more sense once you've understood our multi-cluster architecture. Because data sharing in Snowflake is nothing but the ability for you to securely and govern and in your terms specify a subset of your data that you want to make available to another customer to read. And I like to think of the notion of modern sharing experiences. When you're sharing something with newer technology, you're just giving access and access control. You're not moving data or copying items. So data sharing in Snowflake is I will allow another account to query data from my instance without any data getting copied. And it comes with lots of attributes. So it's almost live, frictionless. There is virtually no latency. It's just if I updated my data, on the other side, you can read it. So if you have any teams doing FTPs and packaging CSVs, or if you're consuming data from someone else and you unpackage and load it and put it in context, all of this is seamless if you share via Snowflake. And we have, at this point, several hundred of our customers are doing data sharing with other entities. When I talk about data sharing, the first thing I hear is like, I don't do data sharing. And then you start thinking like, oh, when was the last time that you have this regular process of emailing Excel spreadsheets? They're like, oh yeah, I do a lot of data sharing. So think about it. The opportunities that this technology opens, and again, strongly enabled by the architecture, are limitless. Then the first few customers that we talked about data sharing, they all said, sounds wonderful. Who else is a Snowflake customer? I want to do data sharing. How do I find out who I can share with? And that's what gave birth to this Snowflake Public Data Exchange, where data providers, and data providers could be any of you. You should not feel yourself left out like, I am not a data provider. No, data providers, anyone that has data that is willing to make it available to others. So if you find yourself in that situation, you can publish data into the exchange. It makes it discoverable to other customers of Snowflake. And then with a single tap on the UI, it imports the underlying share and makes it easier to have data flow between organizations. As Chris said, we talked about public data exchange, and many customers said, this sounds wonderful, but I'm not going to put my data out in the public exchange. I would love to do it with me and my partners, me and my supply chain companies, me and my portfolio companies. And that's what gave birth to the private data exchange. It's not yet announced. We're using this event to start to talk about it. It'll be formally announced with press next month. And the notion is, it's very similar to the public data exchange, with the difference is that you are the exchange administrator. You decide which companies can join the exchange. You decide who can publish, who can consume. You get to see all the activity. And the most interesting thing, which will not be in the initial version of this, but shortly after, is you don't need to have other companies to have a private data exchange. Because at the end of the day, what the private data exchange is evolving into is it's a surface where data is published with some description, some sample queries, some interesting data. And of course, that's what you would want also for your own data within your organization. Right? How do you create? How do you govern? And then we have all these additional projects coming. I'm not going to go into the details on how do we give you even more details on what is in the data, what are the characteristics, help you with data quality, et cetera. So stay tuned. We're going to talk a lot more about the private data exchange. And then my last slide, to recap everything I've discussed today, we see Snowflake as a broadening technology, broadening platform. What we want you to be thinking is about the data and the data that you need to make decisions and get insights, not about features and infrastructure and servers and memory and things like that. Our goal is to give you a seamless set of experiences, both from an amazing query engine, but also security and governance, all the way to global in nature for data that lives either ingested into Snowflake, linked from somewhere else via external tables, or data that you consume via either public or private exchanges. And with all of that, excuse me, we want you to be able to raise the data capability of your organizations. My last closing comment, I don't know how many of you are Snowflake customers today or not. I don't know how many of you will or will not. I hope all of you will, of course. But here's the most interesting thing. What Snowflake has done, it has raised the state of the art of the industry. We're now in a new era. What you should expect and accept of data analytics and data management technologies should be higher, because now you know that it's possible. And that's something that gets me super excited about Snowflake and what we're doing, which is we're raising the state of the art. We're improving the data capability of everyone, regardless of the technology choices that you make. With that, I'll say thank you so much.